Good morning, everyone. Hope you have a good coffee. I didn't. So I'm here today to talk about Supercharged GitHub Actions monitoring with OpenTelemetry at Elastic. Let me put my clock. OK, so it's a bit weird, but yeah. I just put the name of my colleague, Jan Kalanok. He made this call for paper and all the heavy lift, so it's a way to give him the credit. But anyway, my name is Victor Martinez. You already heard twice. I work at Elastic the second time you hear that for over 6 years. I run all the CI/CD automation for the observability team. I would like to talk a little bit about this in the agenda. Right. How many of you are familiar with observability? I know yesterday. OK. Right. OpenTelemetry. OK. I know that Diana yesterday explained a little bit about this. I'll try to sum up a little bit just to put a little bit of context. But the idea is, once I go through this information, I want to explain you what is there about the CI/CD observability, how was our journey, so what we had, what we did, how we tune a little bit the tools, and give you a demo. If the demo doesn't work, I'll have some videos, so at least you see something, but you know. Right. You can see fine there. So you think about observability as a property of the service that you have. And the monitoring is a way you have action. So you monitor through metrics, through the logs. So the idea is all this telemetry data you collect, that over there is traces, logs, and metrics, give you know how to use them, information about why your service is down, right? So you can troubleshoot, or you can have some runbooks to actually fix the problem. So you can apply that to a bunch of different services or entities. Some of them are about your on-premise, or it can be your Kubernetes, it can be your containers, your mobile application. All of these generate data, and that's the telemetry you collect. So I mentioned to you these logs. Probably every application you have send logs to the terminal or to a file. So that's the information. Timestamp normally, that's better. So metrics is about the CPU consumption, or on any other kind of numeric data in a particular time frame. So it helps you to know how much memory you use, how much CPU, what is the build queue, and so on and so forth. And then you got traces. So traces is how much time it takes your operation, and you can visualize that. So it can be how long it takes me my SQL select to run. So you can visualize that particular operation, and then you have a parent-child relationship. So the CI/CD is another service. So you produce data. But you would like to observe as well, because sometimes it misbehaves. So you need to understand what's going on there. So OpenTelemetry is there as, just to sum up, it gives you the APIs, SDKs Diana mentioned yesterday, and it also gives you some framework. So it means there are some semantic in the names. So you can use any vendor, and there are a bunch of different vendors. So Elastic is one of them, but there are as many as you can imagine. Because it's open source, it's not locked to any vendor. Again, I want to focus on that, because once you use any APIs, SDKs from OpenTelemetry, you can choose the vendor you like. It's just to visualize or get other features, like alerting, SLOs, or any other things, right? So the CI/CD observability is already something that 2 weeks ago, they sent this information you can read later on. I'll share with you. But the idea of this is there was a special group that focused on what we could do to observe the CI/CD and provide some semantic naming. So no matter what the CI/CD vendor you use, it's going to have the same names of attributes. So the dashboards you have, all the information you can do, all that you can do with that information will behave the same. So they started like a year ago. And then I want to explain a little bit that this is not something new. So Cyril is a former employee of Elastic. Now I think he's in Grafana. Another colleague of mine and myself, we start working on this as we have experience on Jenkins. So probably you suffer Jenkins, right? So observing Jenkins was good. So we came up with start thinking how we can apply this observability for Jenkins, and we made some plugins, and they start talking about that, and then exploit that there are more people talking about this. So it's nice that even OpenTelemetry has this special group, because it means like all together we can collaborate as an open source project, so we can get benefit from. So this is a little bit of summary of CI/CD, observability, OpenTelemetry. I hope I covered a little bit of the context. But our journey started with something there. How many of you are familiar with GitHub Actions? OK, so if you are not, so it's how you can apply CI/CD using GitHub itself. It's part of the ecosystem that provides you. So the idea in any CI is you have some steps that they can run in sequential or in parallel. But in this case, I want to illustrate how using an action that is there, that someone did, we were able to observe traces, right? And other things like tests. So this guy, I made a note here, I think is Christoph. No, that's not that guy, it's someone else. So made these two actions. So you can actually export all the information from the GitHub action as traces, and you can visualize at a waterfall, so a Gantt diagram, so the same concept. I'll show you later in the demo. And also the test, so we could be able to have some flakiness test detection and so on and so forth. This didn't work well because we have to explicitly, in every single repository, have to have this. So you can enable, disable by accident. So we have a command, right? So you move to GitHub Actions from Jenkins, so we have to have something like infosec could actually run some logs detection for password leaks or any anomalies, right? So Mike and Jan and myself, we work on this idea of how we can provide this uptime of 100%, because we don't want to lose logs. Logs are important if you would like to detect if something goes wrong. So we have to have this idea. It did change a little bit, but what happened is, at the same time in the community, a little bit earlier, there was this idea of, hey, can we have a GitHub Action receiver? I'll explain what is a receiver later, but the idea is, can we actually add observability for GitHub Actions? So this Christoph started this conversation. It evolved as a special interest group, and then we start there. So Jan created this fork from the OpenTelemetry repo, and then we start working about the logs there. OK. So I think I mentioned earlier OpenTelemetry. The OpenTelemetry Collector is a tool. So you can have that tool to receive data, process the data, or manipulate the data, send the data to somewhere else. So on the left hand, this is what we made. So we have Prometheus to be able to self-instrument OpenTelemetry. So we are able to know how many logs or metrics we receive, how many we are able to send. So this idea. So we use Prometheus for that. So then we have specialized receivers for the logs, for the traces, and annotations. I'll explain later on what is the annotation, but the idea is everything that happens in the CI in GitHub, we want that information to be processed. So then there are extensions in the OpenTelemetry Collector, because it's a nice tool that you can use for debugging and optimize. And then you have the processors. It's what you do with the data. So we want to have adding more attributes, or we want to process this information in batches. So we want to be sure that we can accommodate the memory allocation we have with the load we receive, or put some limit in how much memory we allocate to the processor, because if there is a peak of load, we don't want to exploit that. And finally, the exporter is where you would like to send the data to. It can be in the console. It can be in a file. In Elastic, this is the company I work, so I have to put it there. And then it can be anything, so all the vendors I showed you earlier. So this is the idea of the collector. So I'm going to go through what is every single action receiver looks like. So in the black, on the left hand, you can see a typical hello world, maybe. How is the representation in this waterfall as a trace? So the name of the job, you can see there, the action that run the steps, which is the checkout, and so on and so forth. It gives you a sense of what it does. It doesn't give you much context, but it helps you to visualize this with traces. That's one of the receivers. The other one is about the logs. So in GitHub, you can have this view on the left hand, and that's the logs that actually your CI is running, the workflow is producing. So you can visualize that in this case, I put that in Kibana. The other part is about annotations. So GitHub Actions provide you context, but some of this context is not in the logs. So they have this banner on the top about something. In this case, it's a deprecation. What I did, I put this receiver to actually collect that information because it's helpful. So it can be an error, or it can be other things. So we want to have that information to actually do something. OK, this is a proof of concept I did. I don't know, are you familiar with Backstage, any of you? OK, so it's any IDP is the internal developer portal. So anyway, it's where you put some information, in our case, the microservices, APIs, GitHub repositories, GitHub Actions, secrets. So we want to have that there as a service catalog. We want to also have the ownership, who is the team responsible for. So the idea is, on the left hand is Backstage, it's just one repo, and on the right hand, you see some YAML. That's the specific representation of what is a GitHub repository and what are the labels that we consider important for us, the ownership. What I did is I collect that information from Backstage. It can be anything else, anywhere else. And then I put that information as attributes. So I process every single trace or any logs or any metrics, and I actually add this information using the OpenTelemetry Collector. So it's the way you can modify using processors. A processor can be also to remove secrets, because there was an accident in the logs, so you don't want to have that information anywhere else. So what we had is we use autopilot Google Kubernetes, so we didn't want to have a managed Kubernetes cluster. So on the left hand, we have a GitHub application listening for workflows, and then we have some Kubernetes deployment. Let me find this. Didier yesterday talked about Istio. So I put Istio here because we have 3 services listening in 3 different ports. So we have to mirror the payload the information is coming from. So we came up with this solution. But yeah, that's pretty basic implementation in Kubernetes. What we have done is this idea of monitoring everything. I think Joseph explained about this idea of monitoring everything and actually optimize something. So we follow the same principle. So I have enough time. So I'm going to give you part of the demo now. My plan is to show you how we monitor how it behaves Kubernetes and how it behaves the OpenTelemetry Collector, being able to actually understand where we need to focus to optimize the tool we made, right? So you can see here, I got a bunch of tabs. The very first one, can you see from there? Yeah, right? So this is a dashboard that helps us to know how much memory we allocate to the Kubernetes deployment. This is not coming from OpenTelemetry at the moment. It's just a specific Elastic agent specific implementation. I plan to use the OpenTelemetry for Kubernetes, but I didn't have time. But the idea is to understand all the different deployments that you see in colors. We can see how much memory we allocate, right? And when there is peaks of load, well, there's a blank here because I stopped it for something else, and I enabled the other day, and we discovered some memory issues in the implementation. But we can see the resources consumption for the different actually deployments when they start or stop. We can also see how is the GitHub API consumption. When you use GitHub and you want to automate, you create your GitHub application, and there is a rate limit. So the rate limit is you not overwhelm the GitHub with requests. So we have to be cautious, and we realized with the load we have, it was enough with only one GitHub application. But yeah, if I scroll down, you can see here the number of requests per project. So in here, we see the Kibana actually is one of the highest producers of load. In our GitHub Actions CI/CD observability, we can see the number of logs we actually consume per day. And then we can see here other information coming from the pods, right? So again, this is the way we monitor Kubernetes. If I go back to another dashboard, in here, So this is actually what we have now in production. So in the last 2 months, we managed to process over 1,000 million of records of logs, and we only dropped 3 million, so it's less than 0.03% or something like that. So remember the idea of I mentioned earlier with the OpenTelemetry Collector, you have 3 columns, right? Like the receivers, the processors, and the exporters. This is what you see here. On the left hand is the receiver, is how many logs I receive, how many logs I put in memory of the processor, and how many logs I actually send to the exporter. So this is specific coming from the Prometheus metrics. So we use OpenTelemetry, and we actually create this dashboard in Kibana to visualize how it's behaving. So these are the 2 monitoring tools we use to be able to understand if what we put in production is good enough. And I think that's pretty much about the monitoring. So it happens for every single component, logs, traces, and metrics. But yeah, that's the idea. So we can actually see here that has been processed 9 million, but there are 2,000 of logs that hasn't been. So something happens there. OK. So that's a little bit of the monitoring part. But let me go back to where we are. Yeah. OK. So because we have monitoring, we can start detecting some misbehaviors. The main issue for us is the logs. So when you run GitHub Actions, and you actually want to do an action with the logs, if you lose them, there's something smelly. So this is an example. I suddenly, in that particular time frame, we lose a lot of the logs, like 80% or even more. And that's where it comes to this optimize something. The very first thing we did is have an ad hoc implementation with a retry and wait for if it failed. It didn't work. I mean, it works, but this is quite intrusive in the code because OpenTelemetry gives you other tools to do so. So this is for us a no-go. What we did is be able to store logs in the disk and then process them in batches. So we made this implementation like, OK, I receive 1,000 of different workflows in GitHub that finish. I cannot cope with all of them. I'm going to process them in batches, and I'm going to store them in the file system so I can be sure I don't lose the data. This worked well, but then we hit this problem with the memory, with the ephemeral storage in autopilot. Autopilot doesn't let you have ephemeral storage more than 10 gigabytes, so we put the 10 gigabytes in a proof of concept, and then it worked. So obviously, this is not for production ready. Other thing I mentioned earlier is the processor. So OpenTelemetry Collector gives you tools. One of them is the processor. And in the processor, you can say how many logs, traces, and metrics I want to store in memory. When I get to that number, I'm going to send that to the exporter. So by tuning this, help us a little bit of coping with the load we had. But we wanted to play a little bit more, right? Finding actually what is the best configuration what we had, and discover that the more you store in memory and the longer it takes, obviously, has actually a problem, right? So we discovered this configuration didn't work well, and then we came up to, OK, if it doesn't work well, can we do something about the collector itself? Like the memory we allocate never go beyond that number. So there is this limit processor as well, which is native from the OpenTelemetry Collector, that help us to actually save in case of any peak of load. So that helps us as well. So what we end up is, by having this autopilot Kubernetes deployment, having a 700 megabytes of memory usage average, even though we allocate more, we managed to have this service for over 2,300 GitHub repositories. That is about 10,000 builds a day and 30 million of logs. We don't never have issues with the GitHub API rate limit quota, which could be also one of the bottlenecks. So this is good enough for what we have. So it actually doesn't suffer. OK. I have 25 minutes. So I plan to do the demo. I might do my best. If it doesn't work, so you can imagine how it might look, but yeah, let's try. I'm trying to classify this in how you can debug the OpenTelemetry Collector. For such, I need to go to my VPN. Give me a second. So I can access to the collector debugger. Let's start now. Where's the debug? OK, there we are. So the very first thing I want to mention is the OpenTelemetry Collector have a bunch of tools, and this is one of them. You don't need a vendor to actually visualize metrics and traces. You just enable this extension, which gives you some access to some URLs. So let's go there. Give me a second. So I can see here the traces that actually has been received. And so I can click there, and I can, in theory, eventually, I can visualize some information here. Obviously, it's not the nicest UI, but you don't want to have any exporter that can help you to actually analyze. I mean, this is a large scale, so it can be complicated, but it can help you. So this is one way to actually get something from production and be able to debug what's going on there. The other part that I think is important to mention is the profiler. So there is a extension that, because the OpenTelemetry Collector is a Golang tool, so we can actually visualize the heap. We can visualize as well other bits and pieces that actually is quite handy. So let's go back to here. So I can see the number of Go routines I'm using at the moment. OK, you like this, and then other bits and pieces. But I want to show you, if I run this, eventually, I'm going to be able to see how it's behaving my actual implementation. So I can see what are the components that are actually consuming the much more memory. So this is handy when you use as well this flame graph. I don't know if you see that, but for every function that we implement, we can see how much memory we are allocating, and you can drill down to a specific object. So this is handy as well, because it's a way you can continuously profile your application. So that's for free with OpenTelemetry Collector. So it's quite handy in that case. OK, that's part of the first part, the debugging. So let me go back to what's next, is the CI/CD observability. OK, good. Let's go back here. I made another tab. Sorry for so many clicks here. I wanted to be sure I play safe. OK, so this is a view that has been made preview 2 weeks ago, and it's actually collecting all the information for your actions. So it gives you that for free, GitHub itself. So you go to your org in GitHub, you can see here some information that can be handy. So what we did is use the same dashboard with OpenTelemetry Collector data. And it's here. So I don't know, you can see this is a Kibana dashboard. You wonder what is Kibana? It's the UI, right? And then Elasticsearch is what is in the backend. But in any case, this is OpenTelemetry data that we store. So we can visualize here how is the average. There might be some deviation. I don't know how they made the formula. But in this case, we see like the 11% of the builds are failing. And we actually waste 1.4 days of failed jobs. So this is good. You like to see an holistic view of how things behave. Anyway, this is data that you collect. Remember what I mentioned about backstage? So this is how we can actually filter here. We can filter by, hey, tell me all the open source projects, and then you can go to the repository here or the workflow that you would like to inspect, right? So you can drill down. So this is just one way to have an holistic overview of your builds, right? Using this application performance metrics, similar to what GitHub support. I can go to another tab here. It's similar, but this is a little bit different in terms of all the things that we collect. But yeah, the other one was trying to mimic the same behavior. But in this one, it's about all the other things like the top 5 durations and so on and so forth. Again, everything is in the OpenTelemetry Collector, and you can filter by. And the very last one is about an overview as well with the logs, which is the one I produce logs mostly. So I have my log generator here. That's why it produces a lot. And I can see over time how it's behaving. This is my demo environment. Yeah, it's an organization. It's public there. So I just fork a few projects, and I can visualize them here. So that's in the 2 hours. Right? OK, this is an overview, but probably you want to see more about some actions, right? So you collect data, but what you do with the data. That's the important piece, right? So let's go back to some of the dashboards here. OK. So I mentioned to you annotations are important. You want to have some deprecated life cycle, like you use something from GitHub that is going to be deprecated in a few weeks. How do you detect that? So this is a way you can do that. You can visualize how many of these annotations happens, average. You can also see which are them failures or warnings, and actually when there is an action that you would like to do. So deprecated is important, more precisely in the GitHub ecosystem, because sometimes they say this particular Ubuntu runner is going to be away in 2 weeks or in 3 months or so on. So you want to highlight this. This is, again, coming from the logs. So it's a way to actually visualize what you consider important here and make an action. So if you wonder, what is this? This is just, obviously, the repo. And you can filter here by a specific you can filter by the repositories if you consider that important as well. Other things that are important to mention here is Dependabot. I don't know if you're familiar with Dependabot, but you manage dependencies for your project, like what is the dependency of your Maven artifact that you use, or NPM, or anything like that. So Dependabot helps you to do so, but when it fails, it's not easy to know when it fails, and when you have Dependabot in 100 different repositories, it can be handy to have a control plane that you can actually understand how things go, right? So in here we can see the failures that is failing for this demo environment, demo repo I created. We can see here some of the logs like can help us to debug what's going on. And pretty much is because I have some authentication problems, right? But yeah, that's because I made this error happening. But that's all the thing that you can do with the logs. So information you cannot see in GitHub itself, you can actually present that in the vendor you like, because everything is in the OpenTelemetry Collector. OK. I think that's about the dashboards. The other part is about traces and alerting, right? So let's go back to what is a trace. OK, I'm going to use, I thought I'm going to use production, but I'm not sure. OK. I'm going to use a visualization of my demo environment. These are traces. So we use the same APM view for observability. An APM is an application performance monitoring, so it's the same concept. So you have the latency, which is how long it takes that particular workflow to run. In this case, services are repository names, GitHub repositories, and also with the prefix of the name of the organization. But this is pretty much the average build time for the project setup go that might contain several workflows is about this number, right? And this is how many of them are running, and then we can see the failures. So we can drill down to each of them. So I can go to where one of my colleagues work. Where is it? The test container. Here, we can see the transactions, which are workflows, because I'm using this, which is specialized for other things, but it's the same idea of CI/CD observability. So I can see there that it's not failing, and it's taking quite some time. So let's go back there. I can see what is the average time, the failure percentage, and other bits and pieces that are important to mention. But this is the visualization. This is the waterfall for the traces. I can see that it took 32 minutes, and it ran this job. It ran another one, and so forth, and so forth, and so forth. Right? The important bit here is you can start making search about how long it takes to set up Go, how long it takes to anything. And you can ask this question across different repositories, and then you can find out like where you would like to optimize. Right? So it's good for optimizing, because you can ask questions, and then you can find if it happens anywhere else. The metadata is the part that leverage the information, so our attributes that could be important. So in here, I see that it's me, that this run was success, and then I can see what is actually the workflow that run, and the name of the workflow, and other bits and pieces that probably is important. These very two on the top are these attributes that I created on the fly with the OpenTelemetry Collector, but I couldn't find them, so I put unknown. Yeah, that's the information. It helps you also to collect what is the Git, commit, and so on and so forth. The same happened with the correlation. So for every single trace or workflow that run, you can see the logs there. So I can see that information is correlated, so which is handy because you can actually find what is the step or workflow that actually cause any problems. Yeah. This is about the traces view. There's also other cases that could be nice to show you. These are quite about acting. So you collect data, you own the data, but you would like to do something. In this case, what I use is Elastic specific. I didn't figure out if I could do that with the OpenTelemetry Collector itself. Maybe that's for the future, but in a nutshell, I create some view here. Let me zoom down, sorry. Zoom out here. So I can see the rules. So with the data I collect, I can now ask for, hey, tell me if there is any deprecation in the logs, or there is any secret exposure, or if dependable fail. And then doing some search with the attributes, I'm able to actually act, right? What happened here is I have some alerting. I don't know if you see that, but I create my own test for testing the Slack. So I can actually go here and see that something happened that the command not found was actually failing. And I see there in Kibana that there are actually 4 matches that tell me that there is a workflow that actually cannot find this Docker, right? And this is handy because I can see what's the name of the workflow, and I can go to as well what is the repository, which is the test containers go. So I see that this guy is using Docker, but Docker is not in the system at that moment. So this is good because you don't need to actually say the workflow, send me a message if it fails. You can actually act, and with the information you collect, you can actually notify the owners as well. And this is just an example. This is also about secret alerting that I made the other day, where obviously it's running often. I'm running the same jobs over and over to produce some load, but if you consider my super secret password something sensitive, so you can detect that in the logs. Obviously, they shouldn't be here; should be masked. But yeah, you can debug that there is actually a workflow that is exposing in plain English in the public that information. That's certainly something interesting to look at. So yeah, that's another use case that could be nice to have. Okay, and I think the very last one I want to show you is about SLOs. Okay, let me go back to observability, and I go to the SLOs. Okay, this is a concept, and I think that if you use CI/CD, one of the principles is main branch or your trunk branch should not be broken. And if it's broken, in theory, you should go act, fix it, because the longer it takes, the more people can still committing in changes that are not good, so they are wasting time. So in principle, the longer it takes, the more damage it can take, right? So SLOs could help here. What we did is we say a target that 80% of the time, the main branch for this project should be actually green, right? Success. So we can see, well, this is a dependable anyway, but we can use another one. Let me find another one. There's another one. Okay. The scorecards. So this is the name of the workflow. This is actually the repository. We can actually see that We query by searching if the conclusion of the build is success, or we search also for any changes in main, right? We only care about main or master. What happens is we see that every time it runs, it's good, so we are not actually burning any error, right? We are not burning time on that. That's quite handy. If you consider this a way to say the uptime of my main branch should be behave as any other service in the uptime, right? Like SREs use this concept, so I think that's quite nice as well to follow the same principle. Again, this is what you do with the data. This is Elastic specific, but it's another way to what you could do with the data if you would like to have this dashboard. So that's one of the benefits that you could do. I think I touched a lot of ground. Probably I showed you too much Kibana, but Kibana could be any other tool because it's OpenTelemetry Collector, send and collect data from different places and send that to different places as well. I didn't want to use any other one as I didn't want to change in the last moment, but you can imagine you use any other one like Jaeger, Grafana, or any other tool. So in theory, my main goal was you don't need to go to GitHub. You have everything in your vendor, so it could be nice, right? That you don't need to go there. I think all of these are about if something went sideways, but yeah. What is my takeaway here is I probably suggest if you like to contribute, you use any CI/CD vendor in the semantic convention, right? I think there is special groups, as I mentioned to you, in the OpenTelemetry that can help you. You can collaborate. But yeah, my main goal is the more we standardize, the more CI/CD vendors can actually be used because the dashboards I show you, they will work out of the box. That's quite handy. Then this idea I mentioned that we took this concept of divide and conquer. We create 3 different receivers. It worked, but it's not nice, so probably it's better one receiver. So we plan to contribute to the upstream because we've been running this for a few months, and it works. And I think there's a lot of learn we did there. So yeah, we plan to contribute a bit more to the upstream. And I think this should not be only there. There are other receivers that could be important. The test reporting is one of them, because then you can ask questions about what is the test that fail more often. Obviously, there are tools that give you that for free, or not, or you pay for. But I'm talking about the OpenTelemetry itself, the collector. So it could be a nice to have. But it could be also other things, such as if you use attestation as well, or you use SBOMs, or you consider this important as well. It could be also some of these artifacts as well that you can actually collect and send that to your observability vendor, and then that can help. Machine learning could be nice. I didn't explore how we can do anomaly detection in the logs to discover behaviors. But I think we should think about the vision. So it would be nice, in my view, like if we observe the CI/CD and we observe your run production services, how you can correlate failures with the build because they didn't cover the test that you consider important. So I think being able to join these 2 words and starting from observability from the very beginning, like everyone is familiar with, can help also to the future of how things run in production using the same concept. So I think the idea is there. But that's pretty much all. I put some reference here. If you want to read more about the OpenTelemetry CI/CD, these are a few links. If you want to know more about what we did in Elastic with observability, in that case, it's more about other tools such as Jenkins, Ansible, Maven, and so on. But anyway, are there. That's pretty much all. I think you're quiet. I think that's all for me. I just want to say thank you, everyone. Yeah. I think there are no questions, right?
Some questions.
No, there are.
Some are from the comparing to the competitors. So
okay,
I'm not sure if you can talk about that, but let's give it a go.
I hope so.
So the first one is more like, okay, so in your experience, do developers prefer to look at logs in Elastic, or they prefer to just go to the GitHub Actions outputs and like?
That's a good question. I use that a lot, but I normally use the opposite. So I go to the source of truth for one reason. OpenTelemetry Collector is not synchronous, and we don't aim to be synchronous. You can lose data. You can do sample, like only the 80% of the data I want to collect, and so on and so forth. I think this is just, ideally, it would be nice, because no matter what vendor you use, you go always to the same view. But to get there, we are in early stage. So I will say,
and related to that, like, what happens with when the logs are lost? How do you know? Like, because you may be losing part of the information, and it might be important, no?
That's correct. Our main goal first was 100% uptime, so we were thinking to have a supervisor, observing if it's behaving and cache the data. But InfoSec finally did have a different tool, so we didn't end up having this. So the question is, we don't have that support, and we don't plan to do that because our requirements change, but it could be, yeah.
OK, so now it's more at the organization level, considering how big Elastic is. There are a number of questions. So the first one is, how do you enforce the usage of the OpenTelemetry in every workflow? Because you might have hundreds, if not thousands, or whatever. OK,
you just touched something I've been thinking the other day. Is there are repositories that are secret, and probably you don't expose them there. So we didn't think about that yet. But with this approach of OpenTelemetry and the GitHub Actions and the GitHub application, we enforce, because you don't configure that at the repository level. It happens everywhere, no matter what, because it's a webhook coming from the GitHub application itself that sends that information to OpenTelemetry. So we enforce because we use a different approach.
Mm-hmm. Yeah. Now, there are a number of questions comparing to competitors. So,
sure.
So one is asking, OK, why Kibana versus Grafana to monitor all this, or to view at least the metrics?
Right.
And you work for Elastic, so...
No, I'm not going to compare one to another. I could say I probably fail to put more exporters, so you could visualize that actually with the same implementation, you can send data to the different ones. I didn't do that. I thought that last night, but I didn't want to change my demo because, fail can happen. But I can use anything. That's a good thing of OpenTelemetry, and I want to encourage people to think like, the more OpenTelemetry things you use, the more chances you can change to the vendor that works for you. And you don't need to have one. You can have one for metric, one for log, and the other one for traces. It's up to you.
So someone is asking, well, 3 people are asking if we can get these metrics from the GitHub software as a service offering instead, or do you need your own workers?
No, everything I showed you is coming from the GitHub Action runner.
The
so,
the host.
Yeah, the host.
Okay.
Yeah, the hosts are coming from GitHub itself. Yeah.
Yeah, and I think more or less. Yeah, someone is advocating for GitLab instead of GitHub because apparently you are kind of working around some inefficiencies or things that GitHub should have.
Right. This is just to illustrate what you could do in the CI/CD, and I took GitHub Actions because we use that one. So for GitLab, there is also conversations in the OpenTelemetry special group how to support that receiver as well. I know GitLab already have this out-of-the-box OpenTelemetry because they made that a few years ago. We talked to them a long time ago and understood like they have something there. But yeah, it can be any CI/CD vendor. What I want to emphasize is the semantic convention. If an attribute about the name of the repo is the same everywhere, then when you filter in your UI, it's going to behave the same, no matter you use Travis, well, not anymore, TeamCity, any other CI tool.
All right, and this is it. Thank you very much, Victor, because it's not easy to open the second day, so thank you very much for your talk.
Thank you, everyone.
Thank you.
Thank you.
Please welcome Alexander.